Welcome back. We were discussing in Fundamental of Electronics the special purpose diodes. In this lecture, we will focus first on Schottky diodes and then Varactor diodes. Schottky diodes are used for high speed rectification. What are the problems that are associated with the ordinary diodes generally at high frequencies? So for that we have to understand the charge storage principle. Usually in the small signal diodes, they store the charge in the P and the N regions during the forward condition. This we have discussed in very detail how the charge is basically stored in the layer between the P and N regions. So when we switch to reverse bias condition, these stored charges result in reverse current for a very short duration of time. So we will be having the reverse current under the reverse biased voltage. We can see here that the ordinary diode connected with the battery, which is forward biased, and the output is given to the load resistor. We can see that there are charge carriers which are present in the P and N region, and when the battery is reversed biased, then in that case you will be having the reverse current very small magnitude due to the flow of the charge carriers in the opposite direction. So there will be reverse recovery time. The time that is taken for reverse current to fall to 10% of the forward current is known as the reverse recovery time. And this time for the ordinary diode, for an example given by the manufacturer IN4148, is about 4 nanosecond, which is noticeable at frequencies above 10 MHz. So we are interested in high frequencies. At high frequencies, there are some rectification issues. This because the diode will exhibit reverse conduction tails, which deteriorate the rectification performance. So these tails you can see in the output rectification will have some tails which are present at the negative half cycle at high frequency of any ordinary diodes. So when the ordinary diode is given the supply, you have the AC supply at the input and DC supply at the output. So you were able to see at the negative half cycle, there will be the tails appearing for the ordinary diodes. So Schottky diodes have some key features like it eliminates the charge storage. Schottky diodes are basically uses the metal semiconductor junction. For example, the metal can have gold, silver or platinum, and the semiconductor may be N-type silicon. There will not be any depletion layer between the P and N junction, so no stored charges will be there, and hence no reverse recovery time is required. When we talk about the Schottky barrier, 0.25 volt barrier created due to the difference in the electron orbit size between the metal and the semiconductor. This is efficient forward current conduction without any charge storage. So the first turn off can switch it to be faster than the ordinary diodes. During the high frequency operation, the problem which we have seen in the ordinary diode will be removed using the Schottky diode. So it will be having the perfect half wave rectification at the frequencies above 300 MHz. So if you see, it is ideal for high speed switching. So we are using Schottky diode, and the tails are basically removed from the negative cycle of the output wave. This is the representation of Schottky diode, which is different from the ordinary diode in terms of a letter S. So the application, if we see the Schottky diodes, we can use in digital computers. These are the backbone of low power Schottky transistor logic circuits, especially in the digital circuit for faster switching. It is also used for high frequency rectification circuits where fast response is very much critical. So the next special purpose diode we will discuss, the Varactor diodes, which are basically the voltage controlled capacitance. We can think the P and N regions which are acting like a capacitor plates, and the depletion layer is formed as the dielectric. So the depletion layer between the P and N regions act as a dielectric like a capacitor. So the reverse bias will increase this depletion width and it will reduce the capacitance. The capacitance is basically inversely proportional to the reverse voltage. As reverse voltage increases, capacitance decreases. So we can say that the capacitance is voltage controlled. If we talk about the AC equivalent circuit of a variable capacitor for AC signal, then we can think that the depletion layer which is formed in the PN junction diode will have a AC equivalent circuit which is treated as a variable capacitor. This variable capacitor can be represented with a symmetric symbol of a Varactor diodes. So a diode will be there and we represent a capacitor at the anode. So we can see that the Varactor diode is basically the voltage controlled capacitance. So the capacitance with respect to the reverse voltage, we see that capacitance decreases as reverse voltage increases. This feature is used for electronic tuning in communication equipment like TVs and the radios. So here you have the capacitance and the voltage, and when the voltage is increased in the reverse bias, then there will be decrease in the capacitance. So the Varactor is used in parallel resonant circuit with an inductor. The resonant frequency will change with reverse bias voltage, and hence it will be used in electronic tuning of radio stations and TV channels. That is a term which we use capacitance ratio for the Varactor diode. For example, MV209 Varactor has a capacitance of 29 picofarad at a voltage of -3 volt. So minus mean reverse biased. The capacitance will decrease from 6 picofarad at -25 volt. So the capacitance which was 29 picofarad at -3 volt went to 6 picofarad at -2 volt. So giving a ratio of 5:1. So the capacitance is changing with respect to the change in the reverse voltage. If we talk about the doping profile, then there is abrupt junction. So when the doping is uniform, then typical tuning range, this lies between 3:1 to 4:1. Whereas hyper abrupt junction, heavily doped near the junction, allows 10:1 tuning range, which is ideal for AM radios working in the frequency range of 535 to 1605 kHz. So we can see the figure A, which represents the abrupt junction with the doping level and the distance from the junction. So we are getting one straight line. Whereas the hyper abrupt junction, if we see, then we are getting a curve which represent like exponential increase or decrease. So we discussed here the Schottky and Varactor diodes, which are the special purpose diodes. Before this lecture, we have discussed many other special purpose diodes such as the linear diodes and the optoelectronic devices. In the coming lecture, we will discuss some more special purpose diodes, and then we will move to the next lecture. Thank you for now.